Hi everyone. In last session, I discussed Leibnitz theorem and how to find the nth derivative of product of two functions. Okay. So in this session also I discuss some more interesting problems on nth differentiation of functions. As you see this problem, if y is equal to log of x plus root of x square plus 1 whole square, so it is not x plus x root of x square plus 1 whole square, it is log. So that square is there too, that including log. So it is not only for x plus root of x square plus 1. Okay, it is log of x plus root of x square plus 1 that whole square. Okay, so if so, then we have to show that 1 plus x square into yn plus 2 plus 2n plus 1 into x yn plus 1 minus n square yn is equal to 0. So we need to prove this result. To prove this result, first to take the given function y is the function y can be written as, so let y is equal to log of x plus root of x square plus 1. So this whole square. Okay. So differentiate this y with respect to x. Differentiate this with respect to x. If we differentiate this, it gives that differentiation of y is y1. y1 is equal to, first we need to differentiate its power. Differentiation of x square is 2x, like that its differentiation is 2 into log of x plus root of x square plus 1. It is just the differentiation of the power, then inside power log is there. Again we differentiate log. So differentiation of log x is 1 by x. So here its differentiation is 1 by, in place of x we have x plus root of x square plus 1. Again we need to differentiate x plus root of x square plus 1. So because it is a function of function. Okay. So differentiate x, differentiation of x is 1. Differentiate root of x square plus 1. Differentiation of root x is 1 by 2 root of x square plus 1. So the differentiation of root is over. So again inside function is x square plus 1. We need to differentiate that. Differentiation of x square plus 1 is 2x. So now you can cancel this 2 and 2. 2 cancels, and simplifying this, y2 is equal to 2 into log of x plus root of x square plus 1. This divided by I am writing this term x plus root of x square plus 1 into, simplifying this last term, take root of x square plus 1 is LCM, root of x square plus 1 plus x divided by root of x square plus 1. So this x plus root of x square plus 1 cancelled with x plus root of x square plus 1, and you take this root of x square plus 1 as cross multiplication. Root of x square plus 1 into y2 is equal to, sorry, it is not y2, it is y1. So it is not y2, it is y1. Sorry. Make it is y1. So this is y1 into this root of x square plus 1 y1 is equal to, so 2 into log of x plus root of x square plus 1. So again we need to differentiate this with respect to x. So if we differentiate this with respect to x, so root of x square plus 1, differentiation of y1 is y2 plus Again you differentiate, use product rule, first into differentiation of second plus second into differentiation of first. Differentiation of first is differentiation of root of x square plus 1 is 1 by 2 root of x square plus 1. Again differentiation of x square plus 1 is 2x, and keep y1 as it is, which is equal to 2 into differentiation of log of this is 1 by x plus root of x square plus 1. Again root differentiation of x plus root of x square plus 1 is 1 plus differentiation of root of x square plus 1 is 1 by 2 root of x square plus 1. Again differentiation of x square plus 1 is 2x. Close this bracket. So here you can cancel this 2 and 2. Take root of x square plus 1 is the LCM. Root of x square plus 1 into root of x square plus 1 is root of x square plus 1 whole square. Root of x square plus 1 whole square, that into y2 plus x into y1 divided by root of x square plus 1, which is equal to 2 into or 2 divided by x plus root of x square plus 1. So here we can cancel this 2 and 2. Root of x square plus 1 into 1 is root of x square plus 1 plus x, this whole divided by root of x square plus 1. Now we can cancel this x plus root of x square plus 1 and x plus root of x square plus 1. And in both the denominators we have root of x square plus 1. So we can cancel that also. So this root of x square plus 1 cancel with root of x square plus 1. So what is remaining? You write that remaining terms, and also here root and square cancels. Root and square cancels. Now remaining here is x square plus 1, x square plus 1 into y2 plus xy1. You take this 2 to left hand side, it is minus 2 is equal to 0. Now you differentiate this n times, because you see why we are differentiating 2 times means, you see in the desired results they are asking to show this one. In this result we have n plus 2. So that means n plus 2th derivative. If we differentiate 2 times, after that if we apply nth differentiation, it becomes n plus 2th derivative. Okay. So to obtain that n plus 2th derivative, we are differentiating 2 times. Now you apply nth differentiation and you evaluate this one. So applying nth differentiation or differentiate n times, differentiate n times, and by using Leibnitz theorem, we have yes. So nth differentiation of x square plus 1 into y2 plus nth differentiation of x into y1 minus nth differentiation of 2 is equal to 0. Is what is nth differentiation of a product? Product idre hege nth differentiation apply ಮಾಡಬೇಕು. So if the you see I am writing this is so this is the one time I writing separately that nth differentiations. So in next coming problems you should practice to write nth differentiation of this type of functions directly. So ಅದು ಒಂದು ಸ್ಮಾಲ್ ಟ್ರಿಕ್ಸ್ ಏನಿದೆ ಅದು ಹೇಗೆ ಅಪ್ಲೈ ಮಾಡಬೇಕು ಅಂತ ಹೇಳ್ತೀನಿ. ಬಟ್ ಇದು ಫಸ್ಟ್ ಒಂದು ಪ್ರಾಬ್ಲಮ್ಗೆ ಮಾತ್ರ I read the steps. I read the steps of Leibnitz theorems in detail. Okay, only to these problems. In coming problems, you should try to apply nth differentiation directly. As here you take nth differentiation of a product. Nth differentiation of UV is equal to it is NC naught into UVN plus इधे formula ला NC1 into U1 V2 plus NC2 into U2 V3 plus this continues like this up to the term plus NCN into UN V. Sorry, it is Vn. This is Vn minus 1 and this is Vn minus 3. This is Vn minus 2. Vn minus 2 like that. ಅಂದರೆ ಇಲ್ಲಿ u vn ಇರುತ್ತೆ. u ಅಂದರೆ as it is function, vn means nth differentiation of v. Like that u1 differentiation of u is u1 and n minus 1th differentiation of v, and u2 differentiation of u1 is u2 and vn minus 2, like that it continues. Suppose if you wanted to apply that same nth differentiation to this function, ಇದಕ್ಕೆ ಅಪ್ಲೈ ಮಾಡೋದಾದ್ರೆ ಏನಾಗುತ್ತೆ, nth differentiation of x square plus 1 into y2 this is equal to nc naught, it is the value 1 ಬರುತ್ತೆ ಅದು, and u means it is x square plus 1 into vn. If you y2 is the second derivative of y, if you apply nth differentiation again to y2, it gives yn plus 2. y2 ಗೆ ಮತ್ತೆ n times differentiation ಮಾಡಿದ್ರೆ ಏನು ಬರುತ್ತೆ, yn plus 2 ಬರುತ್ತೆ, plus in next step nc1, you know that nc1 value is n, u1 means differentiation of x square plus 1, it is 2x, and vn minus 1 means n minus 1th differentiation of y2, or better thing is you reduce a one number from this n plus 1. So ಇಲ್ಲಿ ಏನಿರುತ್ತೆ, n plus 2 ಇದೆಯಲ್ಲ ಅದರಲ್ಲಿ ಒಂದು ನಂಬರ್ ಕಡಿಮೆ ಮಾಡಿ, so that is yn plus 1 plus in next step nc2. nc2 means it is n into n minus 1 by 2 factorial, and differentiation of 2x is 2 into n minus 2 the differentiation of y2, or you reduce one number from n plus 1, so it is yn. So if you are getting a constant here, you stop the terms, so because in next steps it becomes 0. Okay, ಇಲ್ಲಿ constant ಬಂದ ತಕ್ಷಣ ನಿಲ್ಲಿಸ್ಬಿಡಬೇಕು. So I'm simplifying this, it is okay, you substitute that values in the above equation, you take it is 1. Okay, finally you substitute that values in 1. So again nth differentiation of one more term xy1. xy1 is equal to, you follow the same procedure, nc naught it is 1 into x into n plus nth derivative of y1 is n plus 1 plus nc1. nc1 means it is n, differentiation of x is 1 and you reduce one number from yn plus 1, it is yn, like that. So you obtain the nth differentiation for xy1 and x square plus 1 into y2, you substitute that values in y1, so now 1 becomes so if you substitute that values here, so then equation 1 becomes, it is x square plus 1 into yn plus 1 plus n into 2x into yn plus 1 plus n into n minus 1 by 2 into this 2 into yn. Okay, this is the nth differentiation of x square plus 1 y2. Similarly, nth differentiation of xy1 is plus x into yn plus 1 plus n into differentiation of x is 1 and differentiation of yn plus 1 is yn. This is equal to 0. Okay, so now we have that x square plus 1 into yn plus, sorry, this is yn plus 2. So this is yn plus 2 plus this is 2nx into yn plus 1 plus You can cancel this 2 and 2. You can multiply this n square minus n into yn plus x into yn plus 1 plus n into yn is equal to 0. So now again its simplification gives that x square plus 1 into yn plus 2 x square plus 1 into yn plus 2 and take all yn plus 1 common factors. So this is 2nx plus this is x into you take yn plus 1 common factor plus n square minus n you take yn common factor plus n. So ಇಲ್ಲಿ ನೋಡಿದೆ yn ಇದೆ, this is the yn. You take yn common factor from that two terms, it is like this is equal to 0 plus n cancel with minus n, it is x square plus 1 into yn plus 2 plus here you take x common factor 2n plus 1 into x yn plus 1 plus n square yn is equal to 0. Yes, so that is, so they are getting minus n square yn, but we have plus n square yn. So let us check what happened here. Yes, it is xy1. So I think it is plus only. So it is plus only. So it is plus only. So better you change in problem itself. So make it is plus. Okay. So it is n square plus n square yn is equal to 0. So be confident in your results. So it is x square plus 1 yn plus 2 plus 2n plus 1 x into yn plus 1 plus n square yn is equal to 0. So some small mistake like this, if you are writing in small mistakes, you correct yourself because it is very silly one. In previous in last class I discussed a problem. Yes, I here in this problem y is equal to e to the x log x. In this problem, so in last step, actually in last step due to some, I don't know, I am not identifying this, I forgot to write n here. Okay, so finally I noticed that, but in the classes videos we can't edit that. So you this is a very small mistake, you correct yourself, you write n and n minus 1. So it is n minus 1 only, not n minus 2, it is n minus 1. Okay, so that type of small mistakes you can correct yourself. Yes, next one more problem on nth differentiation is, yeah, I include one more time. So if the problem is like this, so you see what happened, what you writing when you are writing, what you write when you are writing, it's when you are finding its nth differentiation. It is very easy, you take x square plus 1 as it is. So very simple method is, so if you wanted to find its nth differentiation, you write x square plus 1 first, and for this y2 you make it as yn plus 1, yn plus 2. In next step usually nc1 is there, nc1 means you write its value is n, and you differentiate this x square plus 1, it is 2x, and reduce the number from yn plus 2, it is yn plus 1. Again in next step we have nc2, that is n into n minus 1 by n 2 factorial. So that is n into n minus 1 by 2 you write, and differentiate this previous value. So it is 2x is there, its differentiation is 2, and reduce a number from yn plus 1, it is yn. When you are getting a constant number here, you stop the differentiation process. Okay, so that is very easy method to find its nth differentiation easily. So in next problems, in coming problems, I am not writing this in details. Okay, you try to write the nth differentiation directly. Okay, so you see this problem, if y is equal to cos inverse of y by b is equal to log of x by n to the n, log of x by n to the n, show that x square into n plus 2 plus 2n plus 1 x yn plus 1 plus 2n square yn is equal to 0. Yes, let us go this let us solve this problem. So first to take given function, it is cos inverse of y by b. Cos inverse of y by b is equal to log of x by n to the power n. So now you can shift this cos inverse to right hand side, that is y by b is equal to, then it becomes y by b is equal to cos of log of x by n to the power n. So again you can take this b cross multiplication, we can bring that b to right hand side, y is equal to b cos, and also you can write this is n log of x by n log of x by n, isn't it? So this is because log a to the power m can be written as m log a. So that same thing I am written here. So n log of x by n. So it is n. So the given value is n. So they may change that value, instead of n they may give m like that. Okay, whatever it is. So now you take it is 1. You differentiate 1 with respect to x. So in the result we have yn plus 2. That means we have to differentiate 2 times. After that we apply nth differentiation. So then we obtain yn plus 2. So you write its differentiation. Differentiate with respect to x. Differentiation of y is y1. y1 is equal to b. Differentiation of cos is minus sign. Minus sign n log of x by n, close this bracket. This is the differentiation of cos. Again the function which is inside cos, so we have to differentiate that. N into n is a constant. Differentiation of log is 1 by x, that is 1 by x by n. Again differentiation of x by n. Differentiation of x is 1 by n, because n is a constant. So now this n and n cancels, and this x you take cross multiplication, so then it is xy1. xy1 is equal to xy1 is equal to xy1 is equal to minus bn, or minus n into b into sine of, so it is minus n into b, minus nb sine of n log of x by n. N log of x by n. Again we need to differentiate this with respect to x. Differentiate again with respect to x. So use product rule to differentiate x y1. X into differentiation of y1 is y2, plus x into differentiation of y1 is y2, plus differentiation of x is 1 into y1 as it is, which is equal to minus nb, it is a constant, minus nb. Differentiation of sine is cos of n log of x by n. Again differentiation of n log of x by n is, n is a constant, you keep it as it is. Differentiation of log is 1 by x by n, like previous step. Again differentiation of x by n is 1 by n. Now this n and n cancels. X is remaining in the denominator. You take this x cross multiplication, so then it gives x square y2 plus x y1 is equal to minus n square. This is because n into n is n square, minus n square, and b cos n log of x by n. B cos n log of x by n can be written as y. From equation 1 you can write that is y, that is from 1. Okay, so now it is x square into y2 plus x y1 plus n square y is equal to 0. So now differentiate this n times. differentiate n times. Differentiating each term n times by using Leibnitz theorem. By using Leibnitz theorem, we have, so if you apply nth differentiation to each term, nth differentiation of x square y2 plus nth differentiation of xy1 plus n square is a constant, nth differentiation of y is equal to 0. Not necessary to write this step also, okay. So in coming problems you avoid that, okay. So here nth differentiation of this is, it is very easy. First you take x square and you add n to y2, it is yn plus 2, plus in next step you take n because it is nc1, that is n, differentiate x square, it is 2x, reduce a number from yn plus 1 to, that is yn plus 1, plus in next step it is nc2, that is n into n minus 1 by 2, differentiation of this 2x is 2, reduce a number from yn plus 1, it is yn, plus similarly adhe tara, here you take x, add n to y1, that is yn plus 1, the next step it is nc1 andre n, differentiation of x andre 1 now, so idರಲ್ಲಿ 1 number ಕಡಿಮೆ ಮಾಡಬೇಕಂದ್ರೆ it is yn, plus this is n square into differentiation of y n times is yn, y ನ differentiation ಮಾಡಿದ್ರೆ n times ಏನು ಬರುತ್ತೆ, yn ಬರುತ್ತೆ, okay. So like that. So next step you have to simplify this. Here you can cancel this 2 and 2, 2 cancels. So ಹಾಗೆ ಬೇರೆ ಯಾವ್ದಾದ್ರು terms cancel ಆಗೋದ್ರೆ ನೋಡಿ, it is x square into yn plus 2 plus you take all 2n plus 1 terms common factor, it is 2nx plus, this is x yn plus 1, so plus x into yn plus 1, you take yn plus 1 common factor, plus here it is n into n square minus n into 1 n plus this is n plus n square into yn terms na common factor ತಗೊಳ್ಳಿ. So it is x square into yn plus 2 plus, here you take x common factor, it is 2n plus 1 into x, yn plus 1, plus here plus n cancelled with minus n, n square plus n square is 2n square yn is equal to 0. Actually in the given problem what they are given is that same result they are given, 2n square yn, so it is x square into n plus 2 plus 2n plus 1 x into n plus 1 into 2n square yn is there. You obtain the same result here, okay. See one more law. So this one is lengthy, little bit lengthy problem. So what a time. As you see, you take this one. So y to the 1 by m plus y to the minus 1 by m plus 2x is equal to, so plus 2x is given. So then we have to show this result is x square minus 1 into n plus 2 plus 2n plus 1 x into n plus 1 plus n square minus m square into yn is equal to 0. To prove this result, first to take the given function, it is y to the power 1 by m plus y to the power minus 1 by m is equal to 2x. You can write this is 1 by m plus y to the power minus 1 by m is equal to, you write that y to the power minus 1 by m has sorry, you write that y to the power 1 by m as 1 by y to the power 1 by m. 1 by y to the power 1 by m. So ಹೀಗೆ ಬರೀಬಹುದು ಇದನ್ನ 1 by y to the power 1 by m is equal to 2x. As here you take y to the power 1 by m is equal to, you take y to the power, let y to the power, let y to the power 1 by m, you take it as z. So then what happens? This is z plus 1 by z is equal to 2x. So take LCM, it is z square plus 1 by z is equal to 2x. Now simplifying this, it is z square plus 1 is equal to 2xz. Now you take this is z square minus 2xz plus 1 is equal to 0. It is a quadratic equation. So one thing is we can factorize this, or otherwise if it is not possible to factorize, use the formula to evaluate the quadratic equation, like ax square plus bx plus c can be written as x is equal to minus b plus or minus square root of b square minus 4ac by 2a. It is very familiar result. So now similarly use the formula to evaluate this. Z is equal to minus b, minus of b here is minus 2x. So to minus 2x plus or minus square root of b square means minus 2x whole square minus 4ac, c is also 1, this divided by 2a, so that a is 1 here. Now z is equal to minus of minus plus 2x by 2 plus, so here you can take 4 common factor and keep this 4 outside from this root. So root in the varak bandre 4, so like this. So this is 4x square minus 4 divided by 2. So next step you write z is equal to, so here cancel this 2 and 2. So now x plus or minus, so take this 4 outside from this root, it is 2 into root of x square plus x square minus 1. Take 4 common factor, it gives x square minus 1, and take 4 outside from this root, it is 2 into x square minus 1, this divided by 2. 2 cancels. So that is z is equal to x plus root of x square minus 1. So you take one sign, that is a positive one value I am taken. Z is equal to x plus root of x square minus 1. Again, what is z? So initially we take that z means z is equal to y to the power 1 by m. So you take the original value of z. So z value is y to the power 1 by m. So that is x plus root of x square minus 1. So what is y now? Y is equal to 1 m ಹೋಗಬೇಕಂದ್ರೆ take power m on both side. ಎರಡು ಕಡೆ m ತಗೊಂಡೇನಾಯ್ತು? It is x plus root of x square minus 1 to the power m. So this is method of evaluating the original value of y. So y ಅಂದ್ರೆ ಏನಂದ್ರೆ ಹೀಗೆ ಬರ್ಕೋಬೇಕು first. Okay. Now you start differentiating this. Differentiate this with respect to x. So differentiate this with respect to x. Differentiation of y is y1 is equal to m into x plus root of x square minus 1 into differentiation of, it is m minus 1. Again differentiation of, so this is the differentiation of its power. Now the differentiation of this inside function, differentiation of x is 1 plus differentiation of root of x square minus 1 is 1 by 2 root of x square minus 1. Again differentiation of x square minus 1 is 2x. 2 cancels. Now y1 is equal to m into x plus root of x square minus 1 to the power m, and take this LCM. So its LCM is root of x square plus 1 plus x, this divided by root x square minus 1. Take this root of x square minus 1, cross multiplication. It is root of x square minus 1 into y1 is equal to m into, you see, this is m minus 1, this is m minus 1, power m minus 1. If we multiply these two, so that is x plus root of x square plus 1. This is also x plus root of x square plus 1. So multiplication of these two terms, we have to add its power. Power na add ಮಾಡ್ಕೋಬೇಕು. ಅವಾಗ ಏನಾಗುತ್ತೆ m minus 1 plus 1 ಆಗುತ್ತೆ. So that is m into x plus root of x square plus 1 to the power, this is m minus 1, its power is 1, so plus 1. So this cancels. Remaining here is root of x square plus 1, x square minus 1 into y1 is equal to m into x plus root of x square plus 1 to the power m. So again we need to differentiate this with respect to x. y2 ಬೇಕು ನನಗೆ. Okay, so differentiate this with respect to x. So root of x square plus x square minus 1 into differentiation of y1 is y2 plus differentiation of root of x square minus 1 is 1 by 2 root of x square minus 1. Again differentiation of x square minus 1 is 2x into y1 is equal to m into, its differentiation is first power na differentiation ಮಾಡಿದ್ರೆ m into x plus root of x square plus 1 to the power m minus 1. Again differentiation of this is 1 plus 1 by 2 root of x square plus 1. Again differentiation of x square plus 1 is 2x. So this 2 and 2 cancels, and here also this 2 and 2 cancels. Take root of x square plus 1 is the LCM. ಇದು LCM ತಗೊಂಡ್ರೆ root of x square plus 1 into root of x square plus 1 is root of x square minus 1 whole square into y2. Sorry, it is x square minus 1 only. So this plus x into y1 in the denominator, this whole divided by root of x square minus 1, which is equal to, here m into m is m square into x plus root of x square plus 1 to the power m minus 1. Here also you take LCM, it is root of x square plus 1 plus x, this divided by root of x square plus 1. In both the denominators we have root of x square plus 1. You can cancel that root of x square plus 1 in the denominators, and here this root and square cancels. Okay, so now you multiply the right hand side terms. So it is x square minus 1, it is x square minus 1 into y2, x square minus 1 into y2 plus x into y1 is equal to m square into x plus root of x square plus 1 to the power m, because here this is m minus 1 and its power is 1, m minus 1 plus 1 becomes m, and also you can write it is x square minus 1 y2 plus xy1 is equal to m square into, this can be written as y, right? So you see what is y is? Y is x plus root of x square plus 1 to the power m. Same term is there, x plus root of x square. Sorry, it is x square minus 1. I don't know from where I changed it is x square plus 1. So make everywhere it is minus 1. So this is minus. Sorry, it is x square minus 1. 1 minute. Okay, here also we have to change the sign. So by unknowingly I am writing it 6 minus plus sign. Unknowingly I am writing it is plus sign. Okay, change that is minus everywhere. It is x square minus 1, x square minus 1, this is minus x square minus 1, x square minus 1, this is minus yeah, it is x square minus 1. So it is m square into y, it is m square into y, because y is x plus root of x square minus 1, you take it as y. Take this term to left hand side, x square minus 1 y2 plus x into y1 minus m square y is equal to 0. So now you apply nth differentiation to this function by using Leibnitz theorem. Applying nth differentiation. Yes, apply nth differentiation or differentiate each term n times. Differentiate each term n times using Leibniz theorem. Leibniz theorem. Okay. So then it is very easy. You take x square minus 1 into yn plus 2. Directly you take. So next step it is n. Differentiation of x square minus 1 is 2x. Reduce one number here. It is yn plus 1. Next step it is n into n minus 1 by 2. Differentiation of 2x is 2. And reduce one number here. It is yn. So when we get constant here, so its nth differentiation is over. Ali mugayite first term the nth differentiation. Like that you take the second term x into yn plus 1 plus next step ಅಲ್ಲಿ nc1 ಬರುತ್ತೆ ಅಂದ್ರೆ n. Differentiation of x ಅಂದ್ರೆ 1. So one number reduce ಮಾಡಿದ್ರೆ it is yn. So when you get constant you stop here. Minus m square into last term ಇದ್ರದ್ದು. So the nth differentiation of y is yn is equal to 0. So here this 2 cancels and simplifying this x square minus 1 into yn plus 2 plus you take yn plus 1 common factor and x is a common factor. So then it is 2n plus 1 into x into yn plus 1 plus next yn common factor ತಗೊಂಡ್ರೆ it is n square minus n multiply ಮಾಡಿದ್ರೆ ಇದೆರಡನ್ನು plus n ಇದೆ ಇಲ್ಲಿ minus m square into yn is equal to 0. Here plus n minus n cancels. So remaining here is x square minus 1 into yn plus 1, yn plus 2 plus 2n plus 1 into x into yn plus 1 plus n square minus m square into yn is equal to 0. So this is the required answer. So that same, you notice that x square minus 1 into y plus 2 plus 2n plus 1 x into y plus 1 n square minus m square equal to 0. So we have the same thing here. Obtain the same x square minus 1 into y n plus 2 plus 2n plus 1 into x into y n plus 1 plus n square minus m square into y n is equal to 0. So write properly when you are, don't mistake that x square minus 1 plus 1 like that. So I want to stop this session now. So next class I discuss some more interesting problems on this nth differentiation. Okay, in 1 or 2 sessions this I'll try to complete.